If you are looking to get the atmosphere and a couple of interviews related to the conference KCD Istanbul, then this episode is for you. Welcome back to the Is It Observable YouTube channel. Today's episode is going to be a bit special because here I wanted to share my experience, share a few interviews of few speakers during KCD Istanbul. So I had the chance to be selected to present a talk at KCD Istanbul. So I'm not going to share about my talks, doesn't matter. I'm more interested to share some news and some updates and interviews of a couple of speakers. So I had the chance to see Thomas and Kathy presenting a talk about Falco. I've also met Viktor Farcic. He did a pretty amazing talk, by the way. And we had a talk about security that were very interesting. And last, during this conference, I discovered a fresh new performance testing and observability solutions relying on eBPF called Anteon. So very interesting. So I have included here the interview on Anteon plus the demonstration of their product. So let me know again if you're interested in Anteon and if you want me to do a deep dive on it. I would love to share that. So drop me a comment below and I will be notified that I will do an extra episode on that. If you enjoyed today's content, don't forget to like and subscribe to the channel. So follow me in KCD Istanbul. So it's 3:40 in the morning. It's the perfect time to start traveling. I'm heading to Istanbul for KCD Istanbul. So very excited to get there, to go to this lively country and lovely city. All right, let's get for it.
Katharina. I'm working at Dynatrace. I've been in the cloud native community for about a year now, and yeah, having a good time at KCD Istanbul right now.
And me, I'm Thomas in French. I'm working at Sysdig as a developer advocate for an open source project called Falco, a runtime security project. And I'm also a CNCF ambassador for almost a year now.
Yeah, I have done last year a talk about least privilege and how we applied it in our team. And after that talk, actually, Thomas approached me and told me, hey, we could go much further with this and we could improve it a lot. And that's what we're going to present at this conference.
Yeah, basically the idea, when I first time watched the talks from Katharina, it was a really great talk with nice ideas, but I told her my project, the project I'm working for, Falco, we could complete your talk by securing things, by monitoring things to be sure all you present, all the advices you give are well made, well implemented. And basically the main idea was to close the loop. This is why we have that in the title now, is how to apply things and how to be sure we apply them correctly.
For me, it's in the details. Like with least privilege, it's not something you implement once and then you're done with it. It needs to become like part of your definition of done. Because every time you're adding new things, you need to take care of it, you need to think about it. And it just needs to become the mindset of the team. And the tool we're adding, Falco, just helps you to lose or to get rid of any blind spots. And for me, that's the important part, to not forget it and always repeat it, always have it in your mind.
Exactly. The main philosophy of Falco is to detect suspicious things that may happen in your clusters, pods, containers, or hosts. As long as you have a Linux kernel, it will work. So we detect these suspicious things, suspicious events, and we correlate them with rules, and then we trigger alerts. This alert can be consumed by, we have now something like 65 different integrations. So technically you can forward the Falco alerts to an SIEM like Elasticsearch, or Slack to notify your teams, or even to some serverless function as a service systems to react, and this in real time. This is the main philosophy of Falco. We also have other sources of events, because thanks to plugins, we can now ingest any kind of event you may have. So for example, we ingest the syscalls, so to detect suspicious events at the pod, kernel, or host level. And we can also ingest the control plane audit logs, but also the CloudTrails from Amazon, the GitHub webhooks, the Okta security logs, any kind of events you may have, as long as you develop the plugin for. It's quite easy to do. And then you can leverage alerts and then react.
What if you have blind spots? What if you're missing something? And I said, yeah, that's bad. So we need to do something about it. And like with utilizing Falco, and then in our case, forwarding the events to Dynatrace and then processing them there and getting all the information we need out of it, we can really eliminate if we are missing anything, or if we maybe did anything wrong, missed a namespace, missed an old resource, whatever. And we can really ensure that we are not only trying to apply least privilege, but that we really applied least privilege, which is a pretty cool thing.
This is totally the idea behind the least privilege idea. Basically, you will block, well, you will allow only legit stuff, legit actions with Kyberno, OPA Gatekeeper. I think other tools exist. And if you miss something, if you basically forgot one item and this item is exploited by some hacker, you'll be notified by Falco, and then you can react, notify your team, and improve your roles in OPA or Kyberno.
About everything. Everything related to running serverless applications as self-managed solution, right? That means Kubernetes and crossplane and open function, which combines Knative and Shipwright and Dapper and a few other things like Tecton pipelines and quite a few technologies crammed into 25 minutes talk. The value of open function is more like, hey, you need Knative, you need Dapper, you need Shipwright, you need pipelines. How do we put it all together, right? So it's more like a tool that glues it all together, but you definitely don't need open function. You can use some of those tools alone, right, without open function. Knative is basically all about scaling your applications up and down, including zero replicas, and queuing your requests so that if it scales to zero, you don't lose requests. It waits until it goes up and so on and so forth. Shipwright is a tool that combines other tools to build container images and push them to registry, like Knative, for example, would be one potential way how to build container images using Shipwright. Dapper is great because it allows you to not think about databases and how to connect to them and so on and so forth. Dapper automatically figures out how to forward requests to a database of whichever kind you're using. What else is there? Tecton is there. Tecton is used to run pipelines, right, to execute tasks that are required for something. Argo CD, which is not included there, but you can definitely use it because you can use it with any Kubernetes resource, is there to make sure to synchronize whatever is in Git in terms of the state being applied to the cluster. What you can configure it is rules like, hey, have a replica for every 100 concurrent requests. minimum number of replicas should be this, maximum should be that, and things like that. And then also it has certain metrics, a certain observability, which you can plug into any OpenTelemetry or Prometheus type of solution. Mostly the parts related to the network traffic itself, right? So how many concurrent requests are happening, what is the latency of those requests. It actually, that's not the part that Knative itself does. When you install Knative, you configure it to use, let's say, Isti or Linkerd or something like that. And those metrics are collected by Service Mesh in most of the cases.
I'm Jona Apelbaum. I'm an SE manager at Wiz, and I manage Southern Europe, Middle East, Africa, and Latin America. So essentially Southern Europe and emerging markets. We're opening new markets with a small team, and we're building out a team.
Thank you, Jona. And I'm Nicolas Ehrman. I'm a product marketing manager. Also, I'm working at Wiz, and I'm covering mainly the product area in relation to Kubernetes, containers, serverless, and cloud-native applications. You know, as soon as you start to creating your own application, so you write your code, so you are using like open source libraries and so on. So the main things to know is, are you using like vulnerability or library with vulnerability in there and so on? So just scanning the code as soon as you can. So as you're writing it, so you can use like SaaS open source solution to do that, or like a code scan like SonarQube and so on. And then moving further into the pipeline or the software lifecycle, so you can also like start to scan the container images because you are using base images from a container registry, like public registry, and you want to know where they are in terms of vulnerabilities or malware or whatever, and you can use like tools like 3V or even other tools to scan the container images and it start to remediate as soon as you can your image and code.
And just to add on to that, from the developer side, it's important to keep it as transparent as possible from the developer, because the developer needs to focus on code and not bother about security, right? And so the reason we also need to protect runtime, because we need to make sure that nobody puts in images that haven't been scanned or that haven't been through the initial gates, and put control gates at the Kubernetes level. So the first gate would be, for example, an admission control like gatekeeper, right, from OPA, where you can then say, for example, okay, I need this label, or I can't have too many permissions on my pod, or these type of things, right? And then when we move further into the cluster itself, it's important that we keep on checking the configuration of the Kubernetes cluster itself to make sure there is no dangerous configurations are being set, because I can go and change service accounts once it's there, right? So we need to make sure that that's not happening. And then once we go into the container, we need to go and check the runtime. Like somebody goes in and tries to reach a crypto mining website, or tries to change a host file, or tries to anything on the machine that is not good, or try to run a vulnerable library, for example. All these type of things we need to do runtime. And this we can do, for example, with eDPF. And yesterday, Liz Rice talked about Tetragon, excellent example, on how we can act on the kernel level and make sure that no malicious activity is happening.
I think we decide to go with OPA, but we also mentioned Kyberno in the talk anyway. So for us, that's the two main admission controller used by the community. So we don't have any preference, and we are not there to give some preference. It's more like the thing that you need to think about, and having an admission controller, whatever it is, OPA, Gatekeeper, or Kyberno, is something that you should have in place.
And personally, my if I can give my personal flavor, right? I personally prefer OPA. We used OPA for a while, and I think it's just a very powerful, like Rigo is a very powerful language. And personally, I will always go into it's a personal choice, and by no means it's kind of an advice to anyone. It's my personal choice. For me, it's OPA because I've been doing it for a while. So I always say, when I talk to customers, I always say, design a system that nobody can get in, impossible, right? So what you're speaking about is, can we limit lateral movement? Can we do any? So one of these things, like solution have been brought to the market, is the like service mesh, right? So you can do this with Cilium, with Istio, with Console, with there is a many Tetrate or any other solution out there that will make sure that on the network level you limit how people interact in between services.
I was about to mention network policies.
Absolutely, also a good option.
Because okay, you have service mesh, but then you had another layer in the complexity of Kubernetes that is already a little bit complex. So you can also just use what you have out of the box. And of course, one of the best practices is to configure like network policies, and that's also what we're going to mention. You know, in the talk, it's like use tools like Kubebench or Kubescape to look at the configuration and how you can harden your Kubernetes cluster using those best practices.
The reason I also Istio is a good.
It's biased.
I'm not not completely, to be honest, but the use case is more when you go to a multi-cluster environment. And multi-cloud environment and multi-anything environments, network policies are good to protect the cluster itself inside the cluster. But as soon as you leave the cluster, you need to have that control, right?
I know some of them. I recall one that called Acure, Nox, something like that. So they have like a KM with a K solution that is looking at, you know, from an identity perspective, looking at what the service account can do if you have too many privileges on those service account, which service account can give access to which services inside the Kubernetes cluster itself. And sometimes also what is important is, you know, when you are also using the cloud, is understanding the service account that is in fact an IAM role in your cloud account that can give access also to external services from the container side. So that's also the thing that we are looking at, but we didn't mention it in that talk, but that's something we will do for the next time.
Important point, because to go at the least privileged access is something very complex, and reason being, people are used to, I'm going to give a user admin permission because I'm not sure what exactly the permission he needs. So for example, if you talk about, it's important to be able to scan or to log the activity of a certain user during a certain amount of time and check what he actually is using, right? And well, in AWS you got cloud native tools like IAM Advisor, right, that can do this. On Azure you can go and look at the Events Hub and see what's coming in and then check it for a certain amount of time. On Kubernetes you get, I'm not sure about which tool, but there must be a tool that can do something similar.
Co-founder of Anteon. We are a Kubernetes monitoring and performance testing tool solution. We have more than 80 GitHub stars and 1 million downloads around the world.
I am very fond of Linux and Go and eBPF. I am developing our eBPF agent Alas.
We have started our company 2.5 years ago as an open source project for the load testing. When it's gained popularity among the community, we converted into the Kubernetes monitoring solution. In the Kubernetes monitoring solution, we are utilizing eBPF to monitor the Kubernetes cluster.
So our eBPF agent is deployed as a daemon set on the Kubernetes platform. We just do a kubectl apply. Other than that, we have a backend, frontend, and load engines on our platform. You can use the cloud for that part, or you can use self-hosted option. You can install it on your own systems on-premise. So there's two options, but you need to install Alas on your Kubernetes cluster if you want to monitor your cluster.
On the load testing side, we have several solutions. First one is Didosify engine. In the Didosify engine, anyone can start a load testing with a JSON configuration file in their terminals. Other option is self-hosted. Users can install our Anteon platform and they can generate some load. It's a no-code scenario builder. There's no scripting needed like JavaScript or something else. Users can generate the data, load, and send requests to their endpoints. The other option is Anteon Cloud. In the Anteon Cloud, users can also generate loads, and the difference between self-hosted and the DDoS Anteon cloud is users can generate from all around the world. We support now 25 countries. You can generate from these countries. As you can see, this is a demo.getanteon.com. You can see the dashboard. There is two main features. One is performance testing, one is observability. Let's start with performance testing. For the performance testing, when you click the new test button, there is some fields. For example, there is a target. You can enter the target endpoint. For example, I enter the google.com, and I can optionally give a step name. I can change the method from get to post or something else. And there's also other configuration parameters, like query parameters like postman, headers, body, authentication. And we have capture environment feature, and we have assertions. For example, if you want to check if the status code is 200, you can just give 200 here, and if it's not 200, it will give you an error. As you can see, all of the platform is no code. You can add several steps by clicking the new test step. By the way, you can import your environments like Postman, or you can import your CSV data into our platform. If you have predefined Postman requests and collections, you can directly import it in our platform, so you cannot recreate it from scratch. In the next scenario, we can define some iteration count and duration, and we can select the load type. It's a linear, incremental, or waved load type, or you can easily set a custom load. You can, for the DDoS Anteon Cloud, you can select the origin request. We have now support 25 countries. When we click the next button, give a name and start the test, it will start test immediately. You can see the live report in here. For example, you can see the response times in average, minimum or maximum, and the test is finished. When the test is finished, you can see the detailed report. For example, you can see the P90, P95 values, or location report. You can see the requests coming from Spain. For the observability part, when we create a new cluster in the Anteon UI, only you need to do is install our eBPF agent into your Kubernetes cluster. It's a basic, it's a very basic and low overhead agent, and just kubectl apply or helm install. You can install it right away. Then in 1 minute you can get all the data for the metrics, service map, distributed tracing, and logs. For the metrics side, you can see the CPU, memory, disk, and network usage. If you have an immediate GPU, you can also see the immediate GPU's temperature or other metrics. For the service map, this is the exciting part. You only install our eBPF agent into your cluster. You do not need to instrument your code, change your code, or add some sidecars or restart your services. All the correlation and network requests will be shown here. If you see a red line here, there's a problem. Latency is very high among the others. You can inspect the bottleneck from here. For example, we can easily find the Postgres service, and when we click that, we can easily see the queries among the other services. For example, this query takes approximately 2 milliseconds. You can easily order by latency or RPS, so you can find the bottleneck of your Kubernetes cluster. We have some filters. For example, you can say, show me the latencies more than 60 milliseconds. Then we can show on the service map side. Or you can set the HTTP status codes among others. We have no much more protocol currently, and we will add more protocols soon. For example, Kafka and Redis is on the way. We currently have HTTP, HTTPS, gRPC, Postgres.
Currently, we are doing distributed tracing on the request level side, not on the function level, like code level. We are connecting the request through TCP sequence numbers on an ingress and egress network traffics on the node itself. And we are using those TCP sequence numbers as a unique identifier because they are not set as incremental, but first unique then incremental, as you know.
When we make a test, and when you also monitor your Kubernetes cluster with Anteon, there's a tab appears like insights. When you select that, it will show the current state of the Kubernetes cluster when the load test is happened. But we are not correlate the data with our request. Currently, we only take the start date and end date. This is the limitation, but we will solve it in the future. We have also logs feature. We released the logs feature 2 weeks ago. It's on the early state. It's only the raw. It only shows the raw text of the log files. But in the future, we will correlate the logs, distributed tracing, and metrics in a single platform. And in the future, we also want to correlate this feature and make an anomaly detection from that data. Because we own the data and we can generate for example, time series model to get the latencies and create an alert, and you get a select message with all the logs, metrics, and traces.
That's it for today's episode related to the conference KCD Istanbul. First of all, if you've never been to Turkey or Istanbul, I just recommend to go there. It's an amazing city. People are so nice. The food is amazing also as well. And also from the KCD perspective, I think the conference is really well organized. So big thumbs up for the organizers. Really interesting talks. And again, I was very happy to discover Anteon, a really interesting solution. I like the eBPF approach and the fact that they're adding tracing and so on. It will be very useful for performance engineers. So it makes sense to be to test it out. Again, if you are interested to get more details about it, let me know so I can maybe produce a dedicated episode about Anteon. If you enjoyed today's content, don't forget to like and subscribe to the channel. So see you soon for another episode.